Hello children, let's start with a new topic of class 12 electrostatics, and the name of the topic is Gauss law and terms related with Gauss law. The objectives related with the topics are define electric flux density and Gaussian surface. Second, state and derive Gauss theorem. Children, let's start with electric flux. Students, the word flux comes from a Latin word which means to flow. The electric field can be quantitatively described by using the concept of electric flux. Now, what is electric flux, children? Electric flux is the number of electric lines of force which are penetrating through a given surface. Here in the picture you can see the surface with area as A. The picture shows electric field lines passing through a given surface. Now children, these electric field lines are normal to the surface. The surface acts perpendicular to the electric field lines. So, these electric field lines, children, can be uniform or non-uniform. So, according to that, we have a formula which relates these electric field lines with electric flux. So, let us study, children, the formula. The electric flux phi is given by the relation phi equal to E dot dA, that is E dA cos of theta. When theta is equal to 0, that means phi, that is electric flux, becomes equal to EA. And when theta is 90, means the electric flux is 0. As cos 90 is 0, therefore flux equal to EA cos of 90, which is equal to 0. Children, let us study some important points related with electric flux. The electric flux through a closed surface depends only on the charges enclosed by the closed surface, but it is independent of the location of the charges inside the surface. I hope children you have understood the concept of electric flux. Now let's study electric flux density. Students, electric flux density is the electric flux per unit area. Since electric flux density is related with area, so we can also call it as charge density, and it can be denoted with a symbol known as sigma. The SI unit of electric flux density is coulomb per meter square. Children, this is all about electric flux density. Now let's come to another term known as Gaussian surface. Children, as you can see in this picture, we have a closed surface. Now, what is a closed surface basically? A surface where we cannot move from inside to outside without passing through the surface. This is a closed surface. So, children, an imaginary closed surface which is drawn around a charge is known as a Gaussian surface. Then let us understand some properties of Gaussian surface. First of all, the Gaussian surface is just an imaginary closed surface. This surface never touches the charge. The Gaussian surface is cylindrical for a line charge and cylindrical charge distribution, but it's spherical for a point charge and spherical charge distribution. Children, I hope you have understood the terms which are related with Gauss theorem. Now let us study Gauss theorem. Carl Gauss was a German scientist. He has contributed a lot in physics and mathematics. So children, let us study Gauss theorem. This theorem states that the total electric flux through any closed surface is equal to 1 over epsilon naught times the net charge enclosed by the surface. Gauss theorem can be mathematically expressed as closed integral of E dot dA equal to Q over epsilon naught. In other words, we can say electric flux phi, which is equal to closed integral of E dot dA, is equal to Q over epsilon naught. Here Q is the charge enclosed by the body and epsilon naught is the permittivity of free space. Children, let's start with the proof of Gauss theorem. Consider a point charge plus Q placed at point O and which has a spherical Gaussian surface, and the shaded portion acts as a Gaussian surface where we need to find the electric field intensity at point P, and the surface has direction given as n cap, which also lies in the same direction as E. So the angle between E and n cap is 0 degree. So children, let us find the electric field intensity at point P. So the formula is E equal to 1 over 4 pi epsilon naught Q over R square, and the direction is along OP. The electric flux phi equal to E dot ds, and which is equal to EDS cos of theta. Here theta is 0, so the formula becomes closed integral E dot ds becomes equal to 1 over 4 pi epsilon naught Q over R square into ds into 1, as cos 0 is 1. Children, here Q 1 over 4 pi epsilon naught and R square are constant quantities, so we shall take them outside the integral sign. We are left with only closed integral ds. As you all know, children, the surface area of a sphere is given by 4 pi r square. So, on inserting the value of closed integral ds, we shall get the answer 1 over 4 pi epsilon naught q over r square into 4 pi r square. On further simplifying, we shall get the answer closed integral E dot ds equal to q over epsilon naught. Children, this is what Gauss theorem states. I hope children you have understood the concept of Gauss theorem. Thank you children.